My name is Alan Sanchez, and the idea behind the Office of the CISO of Fortinet is to be with you every day, with those that make cybersecurity a mission. It's a little bit like Miles Davis used to say about the jazz music. The jazz music changes every day. Now, if you don't play it every day with other jazzmen, you may very well be playing the music of yesterday. And cybersecurity changes every day as well. So what we're doing today, which is exchanging ideas, experiences, and best practices, in my opinion, is the best way to go about securing what is the most precious asset of our world is data. So the presentation is called here, Think Like a Hacker. It is not, as you can imagine, an invitation to become a hacker, or the contrary, but it gives another point of view on our mission, and knowing the phases, the way, the processes, and the tools that the bad guys are using out there also sets a new light on what we do, can do, and should do every day. Because the temptation is quite easy to look at all those devices that we have carefully integrated into a holistic approach of cybersecurity, looking at the various components, making sure work together, they're properly configured to do all those tasks that cybersecurity requires, and say, okay, that's it. Now I got everything covered. And it could be that at some point we have everything covered. Now, once you go outside this, what I call inside-out approach, and you start the way the attacks are conducted, it helps everyone to be more prepared and to prioritize some of the aspect of the response that we will have to make at some point, because we all know in our job it is not if it happens, it's when it happens. So checking the defenses and thinking like a hacker requires to have in mind the three general phases of a typical attack. The first one is the reconnaissance part, and we used to call it get set. It is the moment when some tests are made all around your infrastructure, where the visible assets are explored, where information is gathered without necessarily at this stage sending or preparing or doing anything. However, there's a couple of things that happen that already can help us understand what sort of attack is preparing and start the prevention phase and the response phase already in that first one. But it's not always possible. Sometimes, and we'll see, the sophistication of these phases is so high that they are hidden underneath very legitimate tasks, and we find ourselves down to the get-in phase of the attack, where some of the things that have been spotted, for instance, available credentials or weak passwords or servers or cameras or sensors that have left the factory default settings, all this has been compiled, sometimes in a very structured database. And the second phase aims at using this information to get into the network and actually launch the attack. There's a couple of things that happen here. For instance, very soon, the attacker are trying to convert some user passwords into more sophisticated admin passwords, trying at this point in time to create the possibility to later on get hold of a network either from a human perspective or from a botnet perspective, trying to escalate, to ramp up the authorization chain using the credentials. And then the core, the essence of the attack around with everything that is about gaining access, taking information from inside to outside, and destroy, damage the infrastructure and sometimes the production facilities that is behind it. At this stage, it is quite important to understand that we see an evolution into this sequence, and hackers and organizations are either not doing it in quickly, one after the others. They would let some of the components of the attack reside inside the memory of a router, the vulnerability of an OS, so that when the router gets rebooted or when the OS server gets rebooted, the threat remains and get reloaded into the memory. And some noise is automatically generated, possibly between these three phases and within each of these phases, to make the detection of these elementary components even more difficult to detect. This framework and modeling attacks have been modelized. I'm not going to go into the details of the acronyms you can see here. Lockheed Martin, as you know, is a very famous company working in many areas close to the defense sector. So they make, obviously, cybersecurity part of their DNA, and they have contributed to this modelization. The MITRE Att&CK Framework is also derived from an approach like this one, and all that is standardized into standardization database and organization that sets a light on top of that. But they all have in common what Lockheed Martin once called the cyber kill chain, which is a sequence of a little bit more detailed version of the model I just mentioned, and some of the elementary step of the various three phases that are described are here. The reason why I'm sharing this with you today is you can already start to prepare, to respond, to automatize, or at least to make your organization aware that this may happen in the very primary steps of the attack, where you don't really have this attack being deployed. Weaponization is transforming normal tool into something that will be turned against the organization. One word about the way this evolves at the moment. It is proportionally more devastating as every of this phase remains silent, and that's maybe a novelty, including the last one. So in the past, you take a normal, a typical ransomware, right? Typical ransomware in the get set would spread some little elements, subcomponents of the code that enable encryption, right? And it would be, they would be disjointed, disconnected, and not put into motion. But at this stage, as you go about doing that, you would have the temptation sometimes to create lots of false positives, because a normal zip file has got an encryption mechanism into it. So it will be flagged as a potential malware and maybe stop a traffic that is legitimate. But the point here is, even in the get around, when the attack deploys, some of the next and the new generations of attacks remain silent, and they would be damaging the productivity or the quality of a factory without necessarily advertise itself that it is there. So it's not like a ransomware that in a dramatic way, by all means, by the way, stops your computer and sends you messages in red with a black background to stress you even more. It's something that happens backstage, that, for instance, would decrease the quality of an engine that is being produced in a plant. And after the engine is put in a car, for instance, you see a return rate or a quality rate, and therefore a brain damaging that is happening. So just let's go into a little bit into what happens in the very phases that I described. And again, with this idea of shedding a light on how you could organize yourself from a training perspective, from a response perspective, from a detection perspective, from a risk perspective, in all those various phases. So the goal is to find a target, right? When you find a target, the elementary components that do that would do things that appear to be weird from a user perspective. They may be using some credential to get some upper levels of credential, but they would do things such as opening all the directories that your password enabled to access, destroy all the backup files that your password enables to access. So even if it's made from a very legitimate perspective, the behavior of the malware is not the one that would be used by a normal user. We'll come back on this notion, but it's called behavioral detection. It's like someone comes into your house and take all the keys of all the cars and machines that are available, and all of a sudden you don't hear about it. So that's already a first warning. The moment it gets in, to continue this metaphor of the car, you can hear that someone is starting the car. So it could be one of your children, it could be yourself, but the way the car is used doesn't quite look like the way you would have done it. And that is what we do by behavioral analysis of a typical user. We know that depending on the profile, but the number of directories, the number of applications, the level of exchange with a server expressed in megabytes has a baseline behavioral that a machine learning algorithm could store into a database and detect that. Well, it's quite bizarre that John Smith, that works in marketing, all of a sudden downloads terabytes of data from a marketing or sales database. This is where you can start to trigger some additional control, or depending on the level of risk you want to take, isolate, microsegment, or kill the traffic coming this way. Some of the technologies that are used in the get around phase are the equivalent of setting a beachhead, which is, as I was describing earlier, the infrastructure has been prepared for being taken over by some external instances, or there's a moment where you need to actually associate the subcomponents that have been delivered at the phase before and put them together so that it becomes an executable code for a little while, and then start to do things, exfiltrate some credentials, just take some elements of a database, financial credentials, credit card credentials, or behavioral analytics to prepare a later, more sophisticated attack. But this is the moment when the attacks get executed. And the way we map and we configure the security platform to defend ourselves against that, are mapped and can be with profit mapped to the various phase and the typical way the malware are actually acting. And for each of these three stage and each of these sub-segment, if you want, of the stage, you have existing cybersecurity technologies that are specialized into either detecting or defending and responding to these. I've just put here a very simple matrix of how the typical cybersecurity components would be set into action, looking at this modelization of the attacks. And you have a couple of remarks that come from looking at this matrix. The first time it's a bit complex, right? It's a bit disjointed. And how do you get that to work together, right? And how do you make sure, for instance, that some of these components are not creating, by their own activity of detection or action, a noise that is spotted by another of these elements as abnormal? And then you have like your soldiers fighting or losing times, exchanging information between themselves instead of operating as a whole in one direction and serving one security policy. So your first problem is not the accumulation of these point solutions, is how do you need to get them to work together? The first thing, as you have to do that, and that's is developed in another presentation, that is the methodology and the playbooks. But the first thing you have to do is not to jump on another component to see if the malfunction that you just been detected can be solved magically by one dedicated component. The first thing is to look at it from a single pane of glass that enables you to assess, and we strongly recommend that this assessment is not a purely human assessment. Otherwise, with the sophistication, the speed, and the volume of the alarms, you would just kill your cyber security team to the task. But you look into what you have and you assess what's happening, and you need at this stage to be able to correlate typically between the network alarms, the cyber security alarms, from one end, from one edge, from one cloud, from one app, from one user, and be able to create a mental map of the attack, and then assess the seriousness and size the defense to the actual attack. The temptation is to do too much too soon, and the temptation is to have too much of these subcomponents and not having dedicated the proper amount of time upstream and during for the integration of all these subcomponents. There was a time where we did not quite to do that in an automated way. You could rely on your experience of a security analysts and to immediately spot, recognize, and take some manual step from segmentation to killing the traffic, to isolation, to send to a sandbox, and then come back. But today, the speed and the magnitudes require that you have to have what we call a platform approach. You have to have, at this point in time, an integrated set of security components that primarily speak to each others, and in a way that goes beyond just passing parameters from one app to another. The platform has a level of integration where it's not only that you pass parameters, but the information flow, because at the end of the day, these are pieces of software checking on other pieces of software, if I really modelize that in a very simple way. Now, each of your defense mechanisms has an information flow, has a logic. So it's not just enough to say, okay, integration consists in passing the parameters from the antivirus to the sandbox, because the timing by which this is made is absolutely key. The level of understanding that typically the sandbox and the antivirus do two different things, okay? The antivirus looks at the threat from the outside, recognize a signature, look into a database of signature, a huge one, and assess how close what we are seeing coming looks like what we have already cataloged as being malicious. However, that is significantly more complicated today. First, because the subcomponents of the software that attacks you are coming disjointed. They are dropped in the second phase at different moments. They are activated by other vectors, and it's only during a small amount of time for the sophisticated threat that they get together and start to act on the data, on the infrastructure, on the edge, right? So as you go about doing that, you need the help of the sub-part of artificial intelligence that is machine learning, to be able to assess. And the way it's done today, it gives you a probabilistic number for one elementary component that is in the analysis chain to be malicious, compared to a threshold, pass to the next node that proceeds to another check, and do that a large number of times, compare it to a database of malicious software, then go out, compare it to a database of legitimate software. The two databases are dynamically updated because they may be fueled from threats that we just saw 1 hour ago in another part of your infrastructure, and assess an overall mark, a score that, compared to a threshold, decides what to do with this traffic, and when not too sure, quite close to the threshold, but not yet there, it is sent to another device, the sandbox, that actually executes the code. So you see, if these different phases are not integrated in such a way that these elementary operations are done, without slowing down significantly the traffic, and in a time base that is consistent with the time base of the attack, it's just useless. You can have the best of breed sandbox in the world and the best antivirus in the world. They just don't talk together fast enough and in an integrated enough way to actually protect you. And the kind of trend that we used to see, that is block the traffic and be on the safe side, doesn't work today, because you have real-time based applications such as the platform we're using today from Google, I believe, to do this conference call. You have to respect isochrony. You have to respect other factors related to the quality of service that you. So when not integrated, if you don't have this deeply integrated, broad, and automated way that we call the security fabric, you don't. Not only do you not leverage your investment of these subcomponents, but you could actually have, as I said, some of these components that are fighting against each other and losing cycles and losing precious time into your security strategy. So when we say that, it doesn't mean that all the components have to come from the same vendor. When we deliver this message of an integrated, automated, and broad security fabric, it doesn't mean this holistic view is not a synonymous of monolithic or monopolistic. We have part of the attributes that we associated to this platform is the openness and the ability, as I was saying earlier, to have all those components that are thought and designed to work together and create workflows that are compatible with each other's, right? And it's very good to have only an API, but it's not good enough to have only an API. For anyone that has done integration, what is an API at the end of the day, right? It is, picture yourself, a template in Excel where you have the cells that have a certain type defined that enables the parameters to be passed from an app to another, but you have all the work to do when you have only the API. When you have an API and a connector, it's like this void or full of blank Excel spreadsheet, to carry on the analogy, is actually instantiated and tested with the other application workflow that is your second line of defense. In other words, the sandbox is designed to work with the antivirus. Then all your machine learning algorithms are really worth being played at this stage, because you don't have a series of CPU cycles, you sandbox that say, wait, I don't know that. Then you have to take a decision and talk to the firewall and act on the traffic. So again, when we say it's opened, it means a whole approach from the connectors to the APIs to the full compliance with the DevOps workflow and approaches, and to an extended Fabric ecosystem that does include third-party routing components, switching components, database processes, auto topology, antivirus, and is able to actually merge all this knowledge across the piece. So when you have this sequence of attack that we have contemplated before, and you put that in perspective with your platform, this is where our job as CISO begin, where we have first to decide what is valuable to the attackers. And that is not one size fits all approach. This is something that depends of the very nature of your activity and the right level of risk that your company, your board of directors decide to take. It's a very important, in my opinion, element of our job as CISOs here is we can map the risk, we can create options of defense from super conservative to we'd like to take this risk because part of this traffic that comes to us and that can contain some malicious subcomponents is actually a very important part of our traffic in the value chain creation. You propose these scenarios and these options of risk, and you get your peers in the boardroom to choose which side of the risk they want to be and which level of risk they want to take. And when you map that with the attack scenarios and this thing of thinking like a hacker, then you see your own infrastructure with in a different light, the light that corresponds to your willingness and your abilities to defend your infrastructure, your application, your users from the attacks. We understand as well why it needs to be holistic. An analogy of the holistic approach is a football team. You can have the best player in the world if they don't play together, if they don't have a response plan to an attack and a retaliation plan to an attack. they may be well losing the game. Comes to my mind the French football team in 2002. They were all stars. They were all best of breeds in their own way, but they didn't play together. They didn't score a single goal. They went home after 2 weeks in Korea. If you take out the last one, they were not so known. They were young people, but they were passing the balls to each other. So sorry for the analogy, but that explains a little bit the importance of the circles in the fabric. It's communication between the subcomponents of your defense lines mapped with a consideration of how the attacks work. And this is where you see the reality of the weakness of your defenses. This is where you see that you may have holes in the ability to detect, to identify, and to respond. And then it's important to define what real problems your security team is up against. You remember what Einstein said, if I had a problem to solve and 10 days to solve it, I will spend 9 days defining the problems I have to solve and 1 day to solve it. It's a bit the same here. It's not by configuring separately the various components of your defense line to the maximum, what you believe the maximum of their ability of defense, that you actually end up with a consistent response strategy. It has to be considered in the light of the attacks. It has to be considered in what is it that the risk you are willing to take. It has been considered as a whole, as a holistic approach. As a word of conclusion on this first part is, you can see why openness and holistic can actually improve the protection by integrating in real time teachings coming from all the firewalls that are installed in the world, and that not only yours. There's a database that has been put in place by the Cyber Alliance, where any new subcomponents or articulated attack is analyzed under 3 criteria: how new, how often, and how devastating. And then when it gets over a certain score, it gets uploaded into a global database that is not monetized as is, but that helps the decision-making process of your own AI-based and analysis of defense to take the real decision. I'll give you an example. There are trends into the attacks. Sometimes, as I said earlier, encryption sub-mechanisms are generating alarms that are false positives. But just 1 hour ago, that precise combination that was actually used in the way to decrypt a zip file has been derived into a malware. And you can have the best human analysts in the world. They would tap into their own experience, and they may well let this go, whereas it has been proven an hour ago that this combination was an actual attack. So holistic, open, and dynamic way of going about addressing the threat, defending the threat, and putting this holistic vision of cybersecurity is a key teachings out of the way we consider the attack from the outside to the inside.